This is geometry, first day of Unit 2. We're going to talk about transformations, specifically about the translation. A transformation. Moves or changes a figure in some way to produce a new figure called the image. So we have this original figure. We're going to move it some way. Sometimes we turn it, sometimes we slide it, sometimes we flip it. And the new item that we're going to produce is called the image. Another name for the original, where you're starting before you flip it or turn it or slide it. The original figure, sometimes we call it, or often we call it, the pre-image. That is your first image. That's the one that's given to you. The pre-image. If the original point is called P, the new point is P prime. And when we write that, we do P prime. A translation. A translation, that is a type of transformation. A transformation, there's many different things that count as transformations. A translation moves every point in a figure the same distance and direction. That is a translation. Often we call it a slide, where you slide the image. We're typically sliding it right or left or up or down. A translation does not change the size or shape of a figure. So that means when you do a slide, as we put our polygon and we slide it over and we slide it down, it's going to be the same size and shape as the original was. It didn't change. A translation does not change the size or shape. So we're going to use this graph at the right. How would you describe the translation from point A to point A prime? Notice that little mark above it is called prime. That's the image. That's the new point. So you have your pre-image and you have your image. So this one over here is called your pre-image. And this one where we're ending is called our image. The image has the prime symbol above it. So from A to get over to A prime, we have to go 8 units. So we could call that -8, because for X that implies that we're going left. So we're going left 8 units. And then we go up, which would be a positive number. We go up 2 units. So we could say that we went left 8 units, up 2 units. That would be a description of how you go from your pre-image to your image. If you want to use the same translation for another point, we'll call it 2, -2. That'll be this one here. We'll call that letter B, point B, capital B, where would B prime be located? Think about what that means. What is B prime? Where is B prime? So we're going to move to the left 8. Then we're going to move up 2. So left 8, up 2. And that's going to put us here at this location where we are now B prime. That's the image for the B point. We count its location from the origin. The origin is considered 0, 0. So that is 6 units to the left. So B prime is at -6, 0. We did that by moving point B 8 to the left and up 2. Now let's talk about this point C. Point C is going to be at a location called X, Y. That's a little weird because that's not a specific spot. That is any spot. That's going to be X, Y. Where would C prime be located? If we did the same translation to X, Y, what would an answer look like? What do we do to the X number? Here the X number was 2 and we landed at a spot called -6. How did we get -6? We moved to the left. How many units? From the B, we moved to the left 8 units. And then we moved up 2 units. So in our location compared to the origin, that was 6 units. But we moved 8. So what we're going to do here for our X is say X minus 8. So whatever your X is, you're always subtracting 8 for this rule. And for whatever the Y is, you're always adding 2 for this rule. And when you write your rule out, you always want to start out with an X, Y, because that's the original points, with an arrow. That means you're doing some sort of translation. This is really a transformation. Many of the transformations use this symbol. So it's just a slide. But whatever your X and Y were, you're going to subtract 8 to the X and you're going to add 2 to the Y. Now let's look at our polygon. We have our polygon here as polygon 1. And we want to do a transformation, specifically a translation, to slide it over and slide it up to land at polygon 2. You can describe this translation by X, Y. Here's your rule. This is what you would write. X, Y with the arrow. X plus whatever distance that's going to be. So in this case, they call it A. You're going over A. In algebra, we like to call it H and K, but in this case, we're going to call it A, and then we go up B. This shows that point X, Y, which are all the points that make up this triangle, are going to be translated horizontally, A units, and vertically, B units. Horizontally is right to left, vertically is up and down. if this here was the rule for going from 1 over to 2, what would we do if we moved from 2 over to 1? What's the rule to move from figure 2 over to figure 1? Every rule starts out with x comma y. Then we use our arrow. Then we use a parenthesis x. What are we going to do with x? If you're starting at 2 and you had to move over to 1, how far to the left do you suspect we'd be going? It's not a number. What are we going to represent this distance as? A, distance A. So we're subtracting, because it's left, subtracting A, and then we're moving down, so subtracting, what do we call that? Minus B. So that's practicing writing a rule depending on which direction you're going. When you move to the right, it's positive. When you move up, it's positive. Those are pluses. When you move to the left or down, those are minuses. When you do a graph of a translation, you're going to first graph the pre-image, also called the original. You graph the first image, and you label them, maybe A, B, and C, or whatever we have. Use the coordinate translation rule. That's what these have been. That's a translation, a coordinate translation rule. Here's a different coordinate translation rule. This is another example. This is very specific because it actually has the values of what A and B would be. So you're going to use the translation rule to find the coordinates of the image. And then we're going to graph this image. And we're going to use the prime notation when you label that image. So here's a couple problems practicing this. So I've already plotted out K, L, M, and N. K is here at 0, -2. L is 4, 3. M is 5, 2. And N is 6, -1. So this is considered our pre-image. This is the original spot. All the points that make up this figure. If this is our rule that we're using, this rule tells us what? We're going to take our x and the y. We're going to do a transformation. In this case, it's a translation because of the plus or minus next to the x and y. So x minus 4 implies we're going to go to the left 4, and y plus 2 means we're going to go up 2. So one way we can do this is look at your original point, subtract 4 from the x, and add 2 to the y. So that's -4, 0. What that did is that went 4 to the left and up 2. So there is your K prime. L prime, think about what this would be. What are we going to do to the x value? This says x minus 4. Subtract, very good. X minus 4. So our x in this case is here is 4 minus what the rule tells us, which is 4. Then we start out with y plus 2. The y value is 3, and we're doing a plus 2 to it. So L prime is going to become 0, comma 5. So let's see how that worked out for our L. So if you take point L and you move 4 to the left and 2 up, we're going to be at this spot that is 5 units above the origin. So that is L prime. We can do the same thing for M. So M prime, what is your X? And where our rule was -4, and what is your Y? We're going to do our rule, which is +2. So this is 5 minus 4. So M prime is 1, comma 4. 2 plus 2 is 4. 5 minus 4 is 1. So 1 over 4 up. That gives us our M prime. Sometimes the letters get close to each other. Just get it as close in there as you can. And then our final one, you're going to take the N. You might like to just count 1, 2, 3, 4 to the left, 1, 2 up. You know exactly where you're at. That works. It's the same thing. Or for your N prime, you're going to say 6 minus 4 and -1 plus 2. So your N prime is at 2, comma 1. And when we look at our graph, we see that that landed at 2, comma 1. So then you hook up all the points. And I like to shade in this figure to kind of just show that it's a little unique. It's different than the original. That is our image. And you can see where all the points are. It's really helpful when we start to have the figures overlap each other. Sometimes it's hard to see the figure. That is our image. This is our original. Here we have a new rule. We're going to have these 2 points, but look carefully. This is P prime and Q prime. P prime, Q prime is a segment that is the image. So if P prime, Q prime are where we end up, let's think about this in a graph. If we're going to end up at -3, 4, and 2, 1, that's P prime, Q prime. We applied this rule right here, 4 to the right and 7 down. We applied this rule to some points that produced this location. Where did we come from? Find the coordinates of the pre-image. So what are we going to have to do to figure out where they came from? If we move some points, 4 to the right and 7 down, and we landed here, where did we come from?
4 left and up 7.
4 to the left and up 7. So we could say our new rule is x minus 4 and y minus 7. So we could say that P must be at -3 minus 4 and 4 minus 7. That's -7, -3. That's our P location. And our Q location, we take our X value, which is from our prime, and we subtract, because that's the opposite of what we were doing from the original rule. And our Y is 1, and we're doing the opposite. So our Q is going to be -2, -6. The last one I want to jump down to be sure that we have covered is that when you do a translation, it does not change the size or shape. So if we move over and down, the 80 is going to stay the y plus 3. And the 2x is going to become the 16. And you can solve that.